Hello everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. Now last class we study about what is electronics, what are the major differences of electrical and electronics and types of materials and their energy band diagram, why we prefer semiconductors over metals to make electronic devices. Now in this class we will study types of semiconductor materials and their properties. Okay, now let's begin with types of semiconductor. So there are majorly two types of semiconductor. One is elemental and the second one is compound. The elemental semiconductor element are silicon and germanium. And in compound semiconductors we have gallium phosphide, gallium arsenide, indium phosphide and many others. So if I talk about the silicon and germanium, they are group 4th element in periodic table. And if I talk about compound semiconductor, there are mix and match of group 3rd and group 5 elements. Okay, now discuss all three elements in detail. Here, group 3rd element, group 4 element and group 5 element. So, group 3rd element are boron, aluminium, gallium and indium. Group 4 element are silicon, germanium, and group 5 element are phosphorus, arsenic and antimony. Okay, here we can say that silicon and germanium are elemental semiconductors, and when we mix and match group 3 element with group 5 element, then we consider those as compound semiconductors. One thing noted here that group 3 element are also called as trivalent impurities and group 5 element are also considered as pentavalent impurities. I will teach you these impurities later on when we discuss extrinsic semiconductor in detail. Okay, now we will start with our another topic, properties of semiconductors. Properties. So first major property of semiconductor is they have negative temperature coefficient. What it means that if I apply temperature here, then resistance decrease and conduction increase. This is the term negative temperature coefficient of resistor means negative temperature coefficient. When I increasing the temperature, the resistance value is decreasing and conduction is increasing. Whereas in metal, what is happening here? In metal, when we increase temperature, then resistance also increase and conduction decrease. This is happening in metals. Don't confuse here with temperature and electric field. Electric field has different properties. Here we are talking about temperature properties. Okay. Now I will tell you this in detail. Let's consider this as a metal piece and there are few electrons inside it. Okay, when I am applying a particular temperature here, then what is happening due to the effect of this temperature, the vibration of this electron increasing. And due to this vibration, the random motion of electron inside the plate is increasing. And due to this random motion, the resistance is increasing. Because what is current or what is electricity? As I also said in earlier class that electricity is nothing but a particular flow of electron in a particular direction. So current is flow of electron in a particular direction. But due to this random motion, these electrons are colliding with each other. They are not creating a particular path. If the collision is happening, then resistance is increasing. So this is the basic concept of what metal are doing, that when I increase temperature in metals, then resistance is increasing. So this is positive temperature coefficient of resistance. Metals are positive temperature coefficient of resistance. But what in semiconductor? Semiconductor doesn't follow this property. As we know that semiconductor has a moderate conductivity between insulator and metals. So we have different properties. Now let us discuss this case with semiconductor. Let's say this is a semiconductor plate and there are few electrons. Okay, now if I am applying a particular temperature here, then what is happening due to the effect of this temperature, this electron is and energizing and colliding with this electron. Okay, see here is electron and it is going here and they both are colliding, and here one hole or one empty space is creating. If this empty space is creating, so another electron is jumping here and they forming a path. Similarly here, hole created, this electron jump here, hole created. So this formation of electron hole pair, is increasing, and if this formation of electron hole pair increasing, then conduction is increasing due to the diffusion current. Okay, now holes and electron, they both are taking part in conduction. Now in semiconductor, we can say that diffusion current is increasing, so they are negative temperature coefficient. It means when I am increasing temperature, the resistance is decreasing. This is negative temperature coefficient of resistance. Okay, now the second property we will discuss here is semiconductors are non-linear resistors. Non-linear resistors. Non-linear resistors. Now what this term mean is, non-linear resistance means V is not directly proportional to I. Okay, now what we can have, V and I and R graph. If this is resistance property, then if I am increasing V, I is increasing, and resistance is a linear property of a particular metal. We can say that this is Ohm's law, V proportional to I. But in semiconductor, this doesn't follow. V proportional to I doesn't follow. They have the property of non-linear resistance. Like I can say, if I am talking about a particular semiconductor, then if this is voltage, this is current, then they doesn't follow the path. They must be this kind of resistivity. So this is a non-linear path. Sometime it is increasing here, then is stable, and sometime it will increase, sometime stable, sometime shooting. So this is the non-linear property of a semiconductor. Second property of semiconductor, that they are non-linear resistors. The third property of semiconductor is that we can change their resistivity by applying impurity. So we can change the resistivity. Which is very, very, phenomenal property of semiconductor, that we can change the resistivity by applying impurity to it. You will understand this term more when I will teach you the extrinsic semiconductor. So for now, you can say that three properties semiconductor materials have. First one, they are negative temperature coefficient of resistor. If you increase temperature, resistance will decrease and current increase. Second one is they are non-linear resistors. Ohm's law doesn't follow on semiconductors. V directly proportional to R doesn't follow. The third one is we can change the resistivity by applying any impurity to the semiconductors. So they are the foremost properties of a semiconductors. Now here I would like to tell you one more thing, that we prefer silicon more than germanium. So why? This is the question for today, that why? Okay, now before I tell you atomic structure and other things which I already tell you about semiconductor and metal differences, now I will show you one more thing here. See this. First reason is that silicon has 14 atomic number, germanium has 32 atomic number, and similarly in third shell the outermost shell is, and in germanium the outermost shell is fourth. So they both having +4 charge, but it is in fourth shell. So yesterday I already tell you that farthest the electron has more tendency to lose its outermost shell fast. So in germanium we can say that outermost electron lose fastly than silicon. So the germanium become more unstable at high temperatures or high frequency. It can't resonate good. Why so? Because it is unstable due to the property of this outermost electron. It has more tendency to leave its outermost shell fast than silicon. So this is one reason. The second reason is here. The second reason why we prefer silicon is that silicon is abundant in nature. Silicon is nothing but silica, which is sand. Silicon is similarly sand. Silica oxide. Okay, it is abundantly found in nature, in earth crust, everywhere silicon is there. So silica sand is heated to 2000 degrees centigrade in the presence of carbon, then we can make our silicon from this. So the main reason is silicon is found abundantly in nature. Okay, so we are making silicon as a major semiconductor material to make electronic devices. Now today what we are discuss, I hope you must understand or you understand all this. Now in next class we will discuss few more topics. So if you like my teaching methods or if you like those classes, kindly subscribe my channel. Or if you have any queries or you want that some other topics I have to some few topics left or few topic I didn't teach in which are present in your particular syllabus, you can mention those on comment section. I will try to complete those also. And before completing the syllabus, I will try to you know I will try to match it up with numerical process also, because numerical is the base of electronics. We have to do numericals as more as we can. So the better understanding level, better understanding of a particular student will have in this subject, and interest also create when we do a few numericals on this. So for today, this is much. I will see you in next class. Thank you.